Okay, so this is the resistor lab, and we're doing the tolerance lab. So what we have here are 3 resistors. Okay, and what we're going to do is we're going to color code them and put the value the color code says there. Then we're going to hook them to this meter and see what the meter says they really are, and put those values there. And then what you're going to do is you're going to do a percent difference. So percent difference, your percent error, is color code value minus meter value divided by color code value, and then times 100, because it'll be some decimal number, like let's say it's 0.9 times it by 100, it's 90. And so that's what you're going to find. Well, actually, the errors, these resistors are all plus or minus 5%. So let's see what we have here. And then we have a plus or minus 1% resistor on this card, which is a 3.3K resistor at 1% error. So 3.3K has more than 3 colors. It has 4 colors. So it has orange, orange, black, brown. Orange is 3. The other orange is 3. Black is the number 0. It's not the multiplier this time. So you add a 0. That's a significant 0. And then brown means add 1 0. So that's how you get 3,300 ohms. We'll measure that. So when we look at the meter, this is called a digital voltmeter. Okay. Back when I took this class, it was called a VOM, voltmeter. There was no digital. So this thing can measure ohms, okay? It can measure volts. It can measure AC volts, DC volts. It can measure AC amps and DC amps. And notice it has a plug there that says common. This one says volt and ohms. This one says amps, and this one says 20 amps. So before you could have 20 amps of current flow through something, you better have a special circuit that'll keep it from melting. Okay, so what we did was we have it set here at ohms. I notice there's various ohm scales because you can't expect the same meter to measure 2 ohms to 200 ohms as well as 20 mega ohms. So it sets the scale so it can get a more precise reading. Let's put that back. Okay, when you use one of these, what I like to do is not keep it on all the time. Hook it up, turn it on, take a reading, turn it off, because they have a battery inside, right? And if the battery's dying as you use it, then you're going to get false readings, or it's just not going to show the digital scale. So what I like to do, instead of using this, which is ridiculous, you'll never get an accurate reading like that, we'll take these test leads, put them on there like that. So I have a black one and a red one. Color code doesn't really matter what color you have, but you know, it's nice to be consistent, particularly if you're hooking to power, and red is generally considered the positive end. So what we'll do is we'll color code this one right now. And this guy is, I'm not going to do this within the camera because it's hard to see. This guy is yellow, violet, red. So he's yellow, violet, red. So that's 4, 7, and red is 2, but you added 2 zeros. Okay. This guy is brown, black, orange. Brown, black, orange. So brown is 1, black is 0, and orange is 3, but you add 3 zeros. So this guy's 10,000 ohms. Lastly, this guy is some color. Hold on, I think maybe I have it backwards. Yellow, violet, orange. So this guy's yellow, violet, orange. So that's 4, 7, and orange is 3, but you add 3 zeros. So we have a 4,700 ohm resistor, a 10,000 ohm resistor, and a 47,000 ohm resistor. Very common parts. Okay, let's take the first guy, hook it to the meter, and let's see what it says. Where's the other lead? Goes around. There it is. Okay, just hooking it up like this. There we go. Are we in the field of view? Yeah. We'll turn the meter on. And the meter says 4.67 kilo ohms. 4.67 K, so that's 4,670 ohms. So color code says 4,700 ohms, and this is 4,670 ohms. Your goal here is to do a percent error and see if we're within plus or minus 5%. Okay, turn this off. Change resistors. Take that back. Put this guy in. Turn this on. This one says 9.8. It's kind of varying. It says 9.8, but it's varying from between 9.8 and 9.81. So it's pretty much stable at 9.80. So 9.80K. So it's 9800 ohms. Okay. So it's supposed to be 10,000 ohms. It's 9,800 ohms. Okay. Is that plus or minus 5%? We'll find out. Okay. And I could tell you that's kind of not a good resistor. Now notice this resistor is a little bigger. That's not because its value is different. Notice this guy is 4,700. The middle guy is 10,000, and this guy is only supposed to be 4,700. It's bigger because it has more wattage. Okay, so that's a quarter watt resistor. You could put more current to that before it gets hot and melts. Okay, the physical size of the resistor is not necessarily related to the ohms it has. Okay, so but the physical size of the resistor is related to how many watts it can handle. So we'll put this one on, turn it on, and notice it says 1 because it's out of range. We'll flip it to the 2000K scale, and notice we have 46.2K. Okay, so that's 46200, little comma there. So that's 46,200 ohms. And it's supposed to be 4,700 ohms. Yeah, 47,000 ohms. And this guy is 46,200 ohms. Okay, let's make sure I did that correctly. K is 1, 2, yeah, okay. And it looks like, yeah, there's a 0 right there. Okay, that's correct. All right. All right, so we did them all, except we didn't do the 1%. So the 1% resistor, I kind of already went over. It's orange, orange, black, brown. And so, let's see, are we in the field of view? Yes, we are. So orange is 3, the other orange is 3. Black, if it's not the last one, it's the number 0. And then brown is 1, we're going to add 1 0. So let's hook this thing up. See what we got. I have it on this card because I only have one for the whole class when we do this in periods. And if I don't hook it to a card, it tends to run away on someone's desk and I never see it again. So we'll hook it up just like that. Turn it on. And the meter says 3.28. 3.28K. Or that guy's significant. So that's 3280. Yeah, ohms. So that 8 is significant, that 0 is a placeholder. Okay, so you want to check 3,280 ohms against 3,330 ohms, where that 0 is significant. Okay, all right. So I'm going to leave this for you guys to do. I will scan this and post it for you, and then you can show your work right there, and there for the percent error. And we'll see if we have good 5% resistors. Now the way I do this is resistor number 7, and we put them back in the tube for other labs. So once you get a tube, you stick with it for all the labs so that you know kind of their actual value, and we'll save that for later. Just for the record, this is resistor set number 8. There's resistor set number 2, 1, 2, 3, etc. And that's our lab. See ya.